Hello and welcome to the Akrometrix Part Tracking user training video. Anyone watching this video should have already viewed the Akrometrix Introduction to Part Tracking. From the introduction video, you should have a general idea of what the new part tracking feature is all about. In this video, we will first go through the use and features of part tracking in detail, followed by some advanced tips and concepts that users should be aware of. You should already have a good concept of a typical test using part tracking, so let's look at all the added features in part tracking more closely. Part tracking can be enabled in a few different ways. This includes enable part tracking directly from the camera window context menu. When this is done, the part tracking window appears and we have entered part tracking mode as indicated by the now blue search area. The enable button is also blue and reads enabled. This can be toggled on and off to enter and exit part tracking mode. The part tracking window itself can be opened from the window selection on the main surface measurement window or by hitting F9 on your keyboard. Remember that just opening the part tracking window does not enable part tracking until clicking on Enable. Now let's look at all the part tracking functions individually. A new file type with part tracking is the AKX_track file. This file saves all of the search setting in the part tracking window as well as the search area size and location. This file can be saved and loaded so that part tracking setup is easily repeatable even for different users. Here you will notice that search settings have all been updated. Also under the File menu you have Load Target Image. A target image can be any Akrometrix phase image or picture file. Loading a target image gives the user a static picture with which to optimize part tracking settings without retaking phase images. Part tracking can now be performed on this image. Instead of loading an image from a saved file, the user can check Retain Acquired Target Images under the Options menu. Now any acquisition or track parts command that is performed will save the entire camera window as a target image. This is the easiest and most common way to populate the target image field. All taken images from the camera window will automatically be populated and named in the tabs at the top of the target image window. The final functions at the top of the part tracking window are the options to hide either the model or target images under view. These are easily checked and unchecked to the user's preference. So let's take a closer look at the different variables that can be changed in the part tracking window. For convenience, we will use the target image window to perform part tracking. As you can see, rectangle size has previously been set using either the Assign Rectangle Model function or a loaded AKX track file, so we can leave the window alone for now and look at the number of instances field. This search setting allows the user to specify a specific number of parts that the software should find. By entering a quantity of 2 in this field, the software will find the 2 best fit parts, meaning the 2 parts with the highest percentage of edges found by part tracking. It is recommended that the user set the specific number to the number of samples they wish to find for most tests. Now let's look at the rotation search setting. By setting the rotation tolerance to 0, the software will only look for parts that are in line with the X and Y axis of the camera. The user should note that for both rotation and scale search settings that a value of 0 is not actually right at 0. There is a small level of built-in allowable rotation and scale just to make the software usable with either of these variables set to 0. Here we find that the 2 parts that appear square to the user are found. As we increase the rotation tolerance, a 3rd part is found and eventually a 4th part will be found. The maximum allowable rotation currently set in the software is 30 degrees, which can be quickly set by hitting the maximum button. With rotation maximized, we can now see how changing the scale search setting will affect the parts found. In this instance, even at 0% scale tolerance, all parts are found. This indicates that the rectangle size was accurately chosen for these parts. In order to illustrate the effect of scale tolerance on the dataset, let's increase the rectangle model size by about 5%. With the new rectangle model and 0% scale tolerance, no parts are found when searching the image. However, if we set scale tolerance to its maximum value of 10%, all 4 parts are found in the search area. The scale tolerance feature is highly useful for data consistency among different systems. By defining a rectangle model of the same size, 2 different systems can find the exact same size dataset even with slightly different setups to lens zoom. Before we cover the minimum match field and part tracking, we should talk a little more about the meaning of minimum match along with a little bit more on how the parts are found. The part tracking search functions looks for part edges. The defining characteristic of an edge is a sudden change in light intensity. When the user gives this function a specific rectangle size to find edges around, then the software is tasked with finding patterns of sudden light intensity changes that match with the given model. Minimum match ties directly in with this function. Minimum match is the percentage of edges that the software must locate to decide a part is present. With minimum match set too high, a part may not be found if some regions of the part perimeter exhibit low light intensity change. In this case, the white regions of the heater bulb behind the sample remove the found edge in these specific regions. In this example, as long as the minimum match is lower than the percentage of the edges found relative to the entire rectangle size, then the part will be found by the software. For this example, we will see that this match requirement is between 95 and 98%, which is a very good quality part match. Let's go back into the software now and change around minimum match for our loaded target image all the way up to 95%. With white samples and a dark background, 3 of the 4 parts are still found. In this case, found part number 1 is the sample we just looked at in the previous example. When we increase the minimum match to 98%, the previously found sample 1 is removed from the found parts. Even though 2 samples are still found, this minimum match value is way too high for practical use. Generally, around the 65% range is a good choice for minimum match. In contrast, reducing minimum match to a lower value, like 30%, will cause a different issue in part tracking. Here the 4 parts present are all found, but we also get what we commonly refer to as ghost parts in our found data set. With the software only requiring an edge match of 30%, some of the heater bulbs in the background are enough to define top and bottom edges at approximately the correct distance apart and create a found part. The inset pixels function does not require much further explanation. With inset pixels checked, the found parts are cropped in from each edge by the number of pixels listed. Since Part Tracker finds the very edge of the part, this function will be used for almost all tests. Depending on the lighting conditions of the system and samples, the increased contrast function may be useful to correctly track parts that have similar light levels to their background. This function looks at the grayscale light levels within the search area and spreads these levels across the spectrum of white to black intensity levels. The final button in the part tracking window is Reset to Defaults. This will set all settings in part tracking back to a predefined default and set the search area to full field. We should cover a few more details in the target image window interface. In the context menu, a search function performs part tracking on the shown image, and a search all function which will perform part tracking on all target images shown in the tabs above. These tabs also have a context menu where the user can choose to close one or all of the target image tabs. Users should also be aware that the search area in the camera window can be used to adjust the search area in any target images. Finally, let's take a last look at the thermal profiler interface when in part tracking mode. The previous part tracking video covered the new naming options in thermal profiler. However, users should take careful consideration in choosing part naming options if testing large quantities of samples, as this will greatly determine how the data can be organized in analysis or reporting steps. Again, thermal profiler will prompt the user on the number of parts found before starting the thermal profile. Studio users should now have a good idea as to how part tracking functions, but before using the software, there are a few more advanced details about part tracking that will be helpful to understand. Advanced tip number 1 covers part numbering priority. When samples are arranged in even rows and columns, part number is very straightforward. Parts are numbered from left to right, then top to bottom, as in this example. However, one of the strengths in part tracking is not having to spend time carefully lining up test samples, so users should understand how part numbering is chosen. For example, when we move the 2 center parts, originally numbered 2 and 5, it can be more difficult to say where one row ends and another begins. In the first example, the top center part is still part of the first row, but the bottom center part is now made its own row and is now labeled as part 6. A part's location in the camera window is based on the top left corner of the part. The rows are established based upon 50% of the rectangle model size. If we move the 2 center parts again, we will see that the numbering is changed. The top center part is now part 1 because it is more than half the part size above samples 2 and 3. Similarly, the bottom middle part is within the 50% part size barrier and has been named back to part number 5. Remember again that once a profile begins, the part numbering will not change, which leads us to the next tip. Tip number 2 covers lost parts during thermal profiling and the 35 pixel rule. Part numbering is established in the initial part tracking check taken before the profile is started. If we were to completely remove a couple of samples from the camera window, then the remaining samples would still be correctly named in the following surface measurement. Excluding a part from the track set of parts may lead to extra processing time, but suddenly calling Part 5 Part Number 6 is something that must be avoided. Some examples of how much movement is tolerated are shown as Part Number 5 is moved between different measurements. Now, most likely your sample is not going to completely disappear, but it may move during heating. We have said that the part tracking feature is designed to track parts through small movements during thermal profiling, but it was critical to build in a tolerance to allow part movement and still be confident that the tracked part is the same part we started the profile with. In order to achieve an appropriate balance, Akrometrix has implemented a tolerance of 35 pixels worth of movement from the top left corner of the original part location. Part movement outside of this circle will result in the part not being included in the final results. Don't forget the part can always be partitioned manually from the full field images as a backup. Our final part tracking tip is all about being able to recognize why part tracking may not find a part. Here we have 3 identical samples set up in the system. However, each of these samples has some subtle differences in the minimum match required to find each part. By using higher minimum match values, only the center part is found. This occurs because the background behind the center part is fully black on all sides. As we gradually lower minimum match, the left and right parts will be found. Notice first how the background of the left part lines up with the white heater bulb areas on top and bottom. This will reduce the edge match percentage. The part on the right has been placed with its right edge lined up with the sample support rail. While the top, bottom, and left edges of this sample have good edge contrast, the right edge has almost none. This leads to the rightmost part being found at 75% minimum match. Keep these test conditions in mind if part tracking is having trouble locating any parts in a given test. It is also worth mentioning that whiter painted parts will typically produce the best part tracking matches. Akrometrix equipment users should now install and begin using the Studio 6.0 software release on their studio-capable equipment. Thanks for listening. If you have any questions, please feel free to contact your local Akrometrix representative or visit the Akrometrix website at www.akrometrix.com.